In this video, we're going to be looking at some of the 3D geometry problems that show up a little further in the test. I left the original numbers on here so you can see that a lot of them are showing up around number 61, 62, sometimes 73, 74. So these are going to be a little bit more advanced problems, and there are a lot of geometry formulas and concepts that we have to be familiar with. And throughout this video, I will show you sometimes how you can put this into the HP 35 scientific calculator. But if you use a different calculator, feel free to type it in whatever way works best for you. So when we look at problem 1, we have a cube with an inner diagonal. So that's from one corner back here to the back corner. And we have to know that if we have the side of our cube here, that inner diagonal is equal to that side times the square root of 3. So if the inner diagonal is already given to us, we're going to take that value and we're going to divide it by the square root of 3 to get the side of our cube. And since the volume is the side cubed, then we're going to take x that we just found here and we're going to cube it, raise it to the third power. So these are two formulas you need to know for cubes. The inner diagonal, volume. We could also find the surface area of a cube, which is 6 times the side squared, and we'll see some of those. But those are the main formulas for our cube. So if we were going to put that into our HP calculator, we would have our 7777 inner, 3, we'll hit the square root of x key, and we'll divide, and we'll do 3, and we'll press y over x, or y to x, sorry, y to x, to raise it to that power. So we end up with an answer of 9.05 times 10 to the 10th. For problem 2, we're looking at a rectangular prism. For volume of a rectangular prism, that's just length times width times height. But if we're dealing with surface area, like we are here, we have 3 different types of faces there, and every one of them shows up twice. So we'll have 2 times length times width, plus length times height, plus length. Nope, we already have length twice. I already forgot which ones I'd used. We want width times height. So that's a little bit hard to read. We're doing 2 times length times width, plus length times height, plus width times height. So I always start on the left-hand side and move to the right and make sure I don't kind of forget any of these. So we're going to just start with what we're multiplying here. So we have 5.28 that we're going to multiply by 7.28. And then I stick with that same starting one. I'm going to do 5.28 again and multiply it then by the other value I haven't seen. And then what I have left are the two that are on the right here. So we'll have our 7.28 times our 2.18. And then all of that then at the end gets multiplied by 2. So if we're putting that into our HP calculator, I would start with what's inside the brackets. I would start with the 5.28, enter, 7.28 times. Then move on to your next set, 5.28, enter, 2.18 times. And then we want to add that to the product that we got for the first set. Then move on to the last set, 7.28, enter, 2.18 times. And we'll add that to the other two sets that we already added together. So those are those 3 faces added together, but since they all show up twice, we'll end with a 2 times. So we could write it in scientific notation, 1.32 times 10 to the second, or you can go ahead and move that decimal 2 places to the right. The other form of our answer would be 132. I would not actually go and write all of that down on a real exam. I would just start typing the numbers directly into my calculator and save that time for working more problems. Moving on to our sphere. Two main formulas we need to know for spheres. One of them is volume. That is 4/3 pi r cubed. We also could find the surface area, which would be 4 pi r squared. So those are the two main things we need to know about spheres. They give us the diameter, so we have to be sure and change that to the radius before we put it into our formula. So we are going to start with our diameter over 2, divide it by 2 to get the radius. We're going to have that cubed. We're going to be multiplying that times pi and 4/3. So that is our volume. And to save time in the calculator and not have to press enter too many times, I do actually start with the diameter like I did when I was writing it down. So to put that in, I would do 0.0051, enter, 2 divide. Now we have our radius. We want to cube that, so we'll type in our 3, y to the x. Pi is on the cosine key, and it's in yellow, so we'll do yellow arrow, and then we'll hit the cosine key, so now we get pi. We want to multiply by pi, so we'll just hit times. You never have to press enter when you're dealing with pi. And then we want to multiply by 4/3. So you could do 4 times 3 divide. That would multiply by 4 and divide by 3. Or if we want to put in a fraction, we can press decimal 4, decimal 3. And that puts in that fraction for us, and then we can just press multiply. So we get an answer of 6.95 times 10 to the negative 8. When it's that large or small of an exponent, I don't move the decimal over that many times. We just leave it in scientific notation if you'd have to write more than 3 or 4 zeros. Okay. We come back to another cube. This time they give us the diagonal of the face, which is just a square. So we have the diagonal of a square. That's just our side times the square root of 2. So that's for a square. So if it was the inner diagonal of a cube, it was x times the square root of 3. A cube is 3-dimensional. And then for square, the diagonal is x times the square root of 2. A square is 2-dimensional. So you can use that to help you remember. Since they do give us the diagonal to start with, we're going to have to take that number and divide it by the square root of 2 to get back to the side. And then our surface area, we set up here at the top, surface area is 6 times the side squared. So we have the side here. We're going to square it, and we're going to multiply then times 6. So if we're going to put that into our calculator, I would start with the 2891, enter. We're going to type in 2 square root, divide. Then we want to square it, so you can either press 2y to the x, or you can press your blue shift arrow and then press x squared. They both do the same thing. Then we'll do 6 times. And that would be moving it over too many times, too many zeros to write, so I just leave it in scientific notation for this one. Okay, moving on to a cylinder. In our cylinder, we have the lateral surface area that we're looking for. So lateral surface area means we're not going to count the flat parts on top and bottom, but we want all of this area. I think about if you have a soup can and you peel off the label is the lateral surface area, not the top and bottom of the can. So if we think about that as a soup label and we take that off, it's really just a rectangle where you have the height of it equal to the height of our cylinder, and then this length across the bottom is this distance around the can. So this is the circumference of that circle along the bottom there. So the way we find circumference, this distance around here, is pi times the diameter, or you could also think of it as pi times 2r, 2 times the radius. So they give us the radius, 800, so we're going to multiply that times 2 to get the diameter. We'll multiply it by pi. So that's the circumference, that's the distance around the circle, or that kind of width of our or length of our rectangle. And then we need the height here. The height is given to us 1900. So this is our circumference times the height. So in your calculator, I would start with pi because you never have to press enter with pi. So we can just do yellow pi. And then we need to multiply by those other three numbers. So we can do 800 times 2 times 1900 times. So you get 9.55 times 10 to the 6th. And that is the format I would leave it in. If we wanted the total surface area, we'd have to take that value and add in these two circles on top and bottom. But since they did not ask for that, we're not going to add those back in. For our cylinder on the right, now we do want to find the total surface area. And this time they give us the whole distance across the circle. They give us that diameter. So we're going to find the lateral surface area first. We're going to do that pi times diameter. And then we have to multiply that times the height. So it's kind of on its side here. But our height is going to be our 3413. So that's our soup label that we found the area of. Now we need to add to that those two circles on the end. So area of a circle is pi r squared. So we're going to have two of those, top and bottom. So we have pi, and then r is half of our diameter. So we have to divide it by 2, and we'll square that. So a little bit more to put into our calculator this time. I'm still going to start at the beginning there with our pi. So yellow pi, 1729 times 3413 times. And then we have to work the circles like they're their own separate little part of the problem. So again, I'm going to start with pi, yellow pi. We need to multiply it by 2, so 2 times. And then we've got to handle everything that's in that squared part. So we'll do 1729 enter, 2 divide. We want to square that, so blue x squared. And then we want to multiply that by that 2 pi that we already have in there. So we'll hit times. So that's going to be the area of those two circles. We already had the area of the lateral surface area in there. So we can just hit plus. And we'll add those two parts together. So we get a total surface area of 2.32 times 10 to the 7th. Okay. If we have a cone that we're looking at, it might help us to recognize that when you look at a cone, that is simply 1/3 the volume of a cylinder. So if we think about how to find volume of a cylinder, that would just be the area of the base times the height. So with our cone, it's just going to be 1/3 the area of the base, which is a circle, pi r squared, times our height. So we have some numbers to plug in. So we're going to have 1/3 pi. Then we're going to have our radius, which is our diameter, over 2. We're going to square that radius. And we're going to multiply by our height. I usually kind of save that 1/3 for the end and just divide by 3 instead of typing it in as 1/3. So you could start with pi or you could start with your radius. They both kind of save a little bit of time. So I actually would probably start with the diameter there. So I'll do 1207 enter, 2 divide. So now I have my radius and I want to square that. So blue x squared. I want to multiply that times pi. So I'll do yellow pi times. I want to multiply it by the height, 3007 times. And I need 1/3 of that. So you could type decimal 1, decimal 3 and multiply. Or we can just type 3 divide. They both end up with the same result, which is 1.15 times 10 to the 9th. Square base pyramid is the same concept as our cone, and that if we had a rectangular prism, 1/3 of that prism is our pyramid. So we have 1/3 area of the base. It's a square base pyramid. So I'm just going to call the side of that square x. So x squared is the area times the height. So we're going to have 1/3. Our side is 6212 squared. Our height is 7518. And again, I do the same thing with the 1/3. I just save it till the end and divide by 3 instead of typing in 1/3. So I'll start with the squared part. 6212. Blue, x squared. 7518. That's our height. We multiply. 3, divide. So we get 9.67 times 10 to the 10th. And at the beginning when you're learning these, you might jot down a few of the formulas just to get them out of your head and something that you can look at to help you plug in your numbers. I would not go to the trouble of actually writing like what I have here. You're simply taking the numbers from the page and putting them into your calculator, into your formula that you have here. So you need to learn to not show your work. We're just typing into the calculator, and then once you're getting good at that, then start leaving off the equation that you wrote down. You wouldn't write the 1/3 x squared h anymore. You just take all those numbers, put them in your calculator, and get your answer. So we have a few more problems that we can look at with some different shapes. We have a right elliptical solid, which is like a cylinder. It's just ellipses instead of a circle. And we need to know how to find the area of our base, because it's not just pi r squared anymore. So we need to know the area of an ellipse is going to be pi AB. And when you look at that ellipse, A and B are like your two radii that are a little different from each other. So you have one that's longer and one that's shorter. So it's not the whole distance across, it's half the distance across each way. So we're going to have that area of the base, we're going to have pi AB, and we're going to multiply that times the height to find that volume. So we're going to have pi. A is going to, and it really doesn't matter which one's A and which one's B. I'm just going to start with the 289 that's on the bottom here going across. I want to divide that by 2 to get half of it. And then my other line going across is 665. We also need to divide it by 2. So that's our pi AB. We've got our height here that we can multiply by, and that will get us our answer. So in our calculator, I would start with pi, and I would do 289, and I'm actually just going to multiply all the stuff that's on the top, because I know that division line means divide. So I'm just going to do, I typed in pi, and I have 289 times 665 times 289 again here at the end times, and then I got those 2's on the bottom, so I'm just going to do 2 divide, 2 divide, and that saves a little bit of time with pressing enter and it taking a little bit longer if you had typed it in a slightly different way. But we get 4.36 times 10 to the 7th. Oh, no. Okay, square base pyramid again. This time they give us the volume and height, and we have to work backwards to find the side of that base. So we said our volume is 1/3 x squared times the height. So we're going to take our volume, we're going to multiply it by 3, we're going to divide it by the height, and that's the side squared. So to undo x squared, we're going to take the square root. So then x is equal to the square root of all of that. So we're starting with our volume, 2718. We're going to multiply it by 3 times. We're going to divide by the height, 23.27 divide. That's x squared, so we're going to hit square root. You get 1.87 times 10 to the first, or I would go ahead and move that decimal to the right once, and you get 18.7. We're back to a sphere. We have the volume given, and we want to work backwards to find the radius. So if we remember from the first page, volume of a sphere is 4/3 pi r cubed. So we're going to take our volume, we're going to divide it by 4/3, we're going to divide it by pi, that's r cubed, so we need to cube root it. And we're looking for the radius. I wrote over it, but we're looking for the radius. So we're going to type in our volume, 929.85, enter. We're going to type in our fraction, 0.4.3. We're dividing by that. We're going to do yellow pi, divide by that. That is r cubed, so to take the cube root, we're going to type in 3. And then it's on the square root key, but it's in yellow. So we're going to press yellow shift, and then that'll take the third root of that number. So our radius is 6.05. I would never write times 10 to the 0 at the end of it. I would just leave it directly like that. Be careful, sometimes they might ask you for the diameter, so when you do that work, you'd get your radius, and if it did ask for diameter, we would end it by saying 2 times, and we'd get 12.1. But they did not ask us for that, so we'll stick with our radius. Okay, another square-based pyramid. This time we are looking for our surface area. They give us the height of a face, one of the slanted parts on the side, and the base of our square. So if we think about the shapes that make up that whole pyramid, we've got a square at the bottom, and we have 4 triangles going around that are all identical since it is a square-based pyramid. So our surface area is going to be our square at the bottom, so we've got our 9.75 squared, plus, and we're going to have 4 triangles, and our formula for the area of a triangle is going to be 1/2 base times height. So we're going to have 1/2. Our base of this triangle is the side of the square, so that's 9.75. And then our height on the side here is actually given to us, which is nice, 7.95. You might instead be given the height of the pyramid, in which case you'd have to use Pythagorean theorem, and you'd have to use half this side of the square over here. You'd have the height given to you, and you could use that then to find this height of the face that we're using in our triangle formula. That wasn't the case here, but that is another form of that you could see. So we're going to go ahead and put this into our calculator. So we're going to have the 9.75 blue x squared. You can look at the 4 and 1/2 and realize that that's just 2. Enter. 9.75 times and 7.95 times. So that number that's showing right now are those 4 triangles. We want to add that to the area of the square that we found right before. So we get 2.50 times 10 to the second, or move that decimal to the right twice, and you get 250. Okay. If we think about our triangular prism here, I picture this coming up here, and we can see then, I'm not great at drawing here, that it's really just going to be half of a rectangular prism, where you've got that flat part in the middle that's that diagonal going across. So if we can think of this as a rectangular prism, and that we just have half of it, that's probably going to be our best approach. Because we have all 3 pieces needed for rectangular prism, we're just going to do length times width times height. But then since it's only half of it, we'll divide it by 2. If you wanted to think of this as an actual triangular prism, this is our base. Our base, we need to find the area of it, and the way you find area is 1/2 base times height. So we'll have 1/2 base times height, and then we'll multiply that base times the height of our shape, and the height of our shape then is 13.2. You'll notice that math works out to be the same as if we did length times width times height and divided by 2. So when we go to type that in, I would just leave the fraction for the end because we can just divide by 2, and that's fewer keys we'll press. So I would start with the 8.7, enter, 9.2 times, 13.2 times, and then for the 1/2, do 2, divide. So 5.28 times 10 to the second, or move that decimal to the right twice, and get 528. Back to a cube, we have our inner diagonal, which we should remember is that side times the square root of 3. So if we just want to find the side, we just take that diagonal, divide it by the square root of 3, and that's it. We don't want to take it any further and find volume or surface area or anything. So 37.9. You don't have to type that 0 at the end, it won't change it. So just 37.9, enter. Then we'll do 3 square root, and we're going to press divide. So you get 2.19 times 10 to the first, or move it over once, and you get 21.9. Okay, spheres. This time we have surface area, which we should know is 4 pi r squared. So we have to algebraically work backwards to solve for the radius, and then use the radius to find the diameter. So be careful with that. So we're going to start with that surface area. We're going to divide it by 4, divide it by pi. That's r squared, so we're going to square root it. And then since that's the radius, we're just going to take that whole thing and double it. So we'll start with our surface area, 12521, enter. And since we were using pi on the bottom, I actually did not have to press enter then. So I'm going to do it again just to show you that we don't have to. So we have 12521, and if I'm going to use pi, I just do yellow pi. And you'll notice that both of those numbers are there for us now. We can press divide. We want to divide by 4 also, so we'll do 4 divide. Then we can do the square root and press 2 times. So we get 6.31 times 10 to the first, or bump that decimal over once and put 63.1. There are different ways you can go about typing this in. I did this one a little differently than I had some of the others, in where I divided by pi and then I divided by 4. I could have also typed in 12521, brought up pi, did 4 times, multiplied 4 and pi on the bottom, and then pressed divide, square root 2 times, and I get the same answer. So it doesn't matter whether or not you multiply both of these before you divide, or if you divide by each one individually. It's the same amount of work and it's the same answer at the end. So whichever makes more sense to you. We have another elliptical solid. We have the major and minor axis. Remember to get A and B, we just divide them both by 2. And we want to find the volume. So that's our pi AB for the area times our height for that solid. So we'll get pi. A is going to be 14.25 over 2. Or it could have been B. It doesn't matter which one's which. We've got the other axis over 2. And then we'll just multiply by the height, which is given as 10.81. Okay. So we'll start with, I'm just going to multiply everything across the top there. So I'll start with my pi, yellow pi, 14.25 times 4.28 times 10.81 times 2 divide, 2 divide. And I get 5.18 times 10 to the second. Be careful how you write your numbers. My 5 I did not write very clearly there, and some people might interpret that to be different things. So just be careful with your handwriting. And I could just go ahead and move that decimal over twice and get 518. If you wanted to spend a little bit more time on the problem and you wanted to divide each axis by 2 before you multiplied, we could have done pi 14.25 enter 2 divide, and then we'd multiply it. Then we could do 4.28 enter 2 divide, multiply it, and then 10.81 times. So if you're more linear minded and want to go just directly left to right like that, you could, but we ended up pressing enter 2 more times than we would have, and that takes just a little bit more time. For our next shape, we have a right regular pentagonal prism. So what that means is we're thinking of the pentagon down here as our base of this shape, and then the height of it is the 7151. So anytime we're finding the volume of a shape like this, it's just the area of the base times the height. And we are going to have a couple of different ways that we could go about finding the area of that triangle. Or not the triangle, of that pentagon that's on the side there. So we're going to start with kind of the side there. So if I think about this as a triangle, okay, I've got 2151 as the side there. And I can figure out what that angle is that's in there, because I know that all the way around is 360 degrees. I'm going to go ahead and just draw this again. Ooh, that's not good. From the middle. So if I take 360, and if I divide it by 10, because there's 5 triangles, but I only want half of it, then I'm going to get an angle right there of 36 degrees. And we know that this part right here is 2151 over 2. So I can use trigonometry, I can use SOHCAHTOA to find the height of that triangle, and then I can find the area of it. So if I look at the SOHCAHTOA of it, I'm going to have the opposite and adjacent. So I'm going to have the tangent of 36 equal to the opposite angle, or the opposite side, sorry, 2151 over 2, divided by the height. Which it's the adjacent in this, but it's going to be the height of our triangle. So I'll go ahead and put A just to make things make more sense. So if I want to solve for A, that means that these have to swap places. So that means this height of this triangle here is going to be 2151 over 2 over the tangent of 36. And to find the area of that triangle, I'd have 1/2 base times height. And then I'm going to have 5 of those triangles in that pentagon. So for that base, I'm going to have 5 times 1/2, and then I'm going to have the base, which the whole base of that triangle was 2151, and then the height is 2151 over 2 over the tangent of 36. So that will be the area of the pentagon, and then we're going to multiply that times the height of that whole solid. So that's going to be times 7151. There are other ways you can find areas of pentagons. That's the one that was just coming to mind right now for me. You might have a quicker way of finding that area. So I'm going to start with the 5, enter. I'm just going to do 2 divide. You might have already recognized that's 2.5 and just typed in 2.5. We'll do 2151 times. We'll do 2151. And if you want to work it like it's in the parentheses like that, we can do 2151 enter, 2 divide. We'll make sure we're in degree mode, which we are currently. So we'll do 36 tangent divide. So now I'm done with that set of parentheses that I have right here. So now I can multiply it by what I've already put in before. And then I can multiply by that height, 7151 times. And that finishes it up. And I get a volume then of 5.69 times 10 to the 10th. I know there's a formula that you can use using the apothem, but that's not coming to me right now. So you can look and see if you can find a shorter way to work that one. Okay. For our tetrahedron, we have an edge that each one of these edges is going to be an equilateral triangle, or the faces that we have there. The edge is 7.71. If we were looking for the surface area, we would use equilateral triangle formulas, but we want the volume, and our equation here is that we're going to take the edge cubed and divide it by 6 square roots of 2. And all of that is derived from the fact that the diagonal of a square is the side times the square root of 2, and that whenever you truncate a cube, when you cut one of the corners off, then that's actually 1/6 the volume of that shape. And so all of that kind of together comes up with this equation that we can use. So we're going to have our 7.71, enter. We want to raise that to the third power, so 3 y to the x. We'll do 2 square root 6, and we'll multiply and divide. So we get 5.40 times 10 to the first, or move that decimal over once and get 54.0. For our sphere, we have surface area, which we know is 4 pi r squared. We want the area of the great circle, which just means that circle that goes through the middle of the sphere, that the diameter and radius of the sphere is based off of. And so that's going to be pi r squared. So if we look at both of those formulas, we should recognize that most of it is they have in common. So really we just need to take the surface area, divide it by 4, and that gets us that area of the great circle. So this is a quick one, 7515, enter, 4, divide. And we get an answer of 1.43 times 10 to the third. We'll move that decimal over 3 times, and that would be the area. If we have a rectangular prism, we could do a lot of Pythagorean theorems in order to find our inner diagonal across here. Because we could have 9 and 12, and we could figure out that hypotenuse. We could use 12 and 13 and figure out that hypotenuse. And then we could use some different equations, and it could get pretty complicated. But a fast way of doing this, an easy way of doing this, would be to just do 9 squared plus 12 squared plus 13 squared, and we're just going to square root that. And I think I got a little out of hand whenever I was drawing those before. You really just would have to do Pythagorean theorem once to get that, and then you could use Pythagorean theorem with that in order to find that inner diagonal. But it would take a little longer. It'd be a few extra steps. So we can just do our 9 blue squared, or just type in 81, and then 12 blue squared, or just type in 144, and we want to add those. And then we have 13 squared, so you can just know it's 169, or you can do 13 blue square. We want to add that, so that's the sum of all 3 of those, and we just square root it. And we get 1.98 times 10 to the first, or move that decimal over 1, and get 19.8. For the next one, we have an icosahedron, and we need to know that with that icosa out front, that means that we're going to have 20 equilateral triangles around the faces of this thing. So one of our edges, one of our sides here is 717. So to find the area of an equilateral triangle, that area is going to be the side squared times the square root of 3 over 4. So our surface area is going to be 20 of these. So we're going to have the side squared times the square root of 3 all over 4. So when you're putting this in the calculator, I would recognize that 20 divided by 4 is going to give us just 5. So I would not type both of those in. I would just use 5 there. And I'm going to start with the 717 because I'm going to do blue squared. I don't have to press enter anytime I do those operations. I can go ahead and do the 5 times at that point. And I'll do 3 square root times. So we get 4.45 times 10 to the 6th. You could go ahead and move that decimal over to the right and have 4450000. I never write more than 4 zeros. Sometimes I'll just stop at 3 zeros. But that would be the maximum I would ever write. For our cube, we have the inner diagonal. We want the surface area. So inner diagonal is the side times the square root of 3. So we'll divide it by the square root of 3. That's the side. We know that in order to find the area, we need the area of that side. So that face, side squared. And then we'll multiply that times the 6 squares that make up the faces of our cube. So in the calculator, we'll take our 72.15, enter, 3 square root divide, blue squared, 6 times. So we get 1.04 times 10 to the 4th, or move that 4 times over, and we get that value. Okay, we have the diameter given, and we want the ratio of the volume to the surface area. And so we are going to just go ahead and write out those formulas and see what we can go ahead and reduce out. So volume is 4/3 pi r cubed, and our surface area is 4 pi r squared. And ratio just means we are going to divide them in that order. So if we look to see what the top and bottom have in common that we can reduce out, we've got a pi that goes away. We have r cubed over r squared, and we should recognize then that that's just going to leave us 1r on top. So r squared is gone, and that is now r to the first power, which is just r. We've got 4/3 divided by 4, so the 4's go away, and we're left with just 1/3 r. And that's it. 1/3 r to the first, everything on the bottom reduced out. So we need to take our diameter, we need to change it to the radius, and we need to divide it by 3. So 72.55 divided by 2 for the radius, and then we'll just divide that sucker by 3. So we'll do 72.55 enter, 2 divide, 3 divide. Or you might have recognized that that means you would have done the diameter divided by 6, and we could come up with it that way. We could move our decimal over 1 and get 12.1. I haven't mentioned it yet, but on the exam, of course, you would just write one version of that or the other. You either write it in scientific notation or you write it in standard. You do not write it in both forms. I'm just showing you both, so no matter how you're going about writing your answers, you should see one that matches what you should do. Okay, rectangular based pyramid. So we got to be careful. This is not a square at the bottom, it's a rectangle, and we want the surface area. So we're going to have 2 different types of triangles, one along the width and one along the length of that rectangle. So we are going to just start with the rectangle at the bottom. We're going to have our length times our width, or however you want to say it. And we're going to add to that 2 triangles. The triangle area is 1/2 base times height, so we've got our 1/2 there. And this one's going to require a little bit more work. So I think actually I'm going to restart this beneath here with a little bit more room for us to see what's going on. So I'm going to start here on the left, and we're going to have the rectangle area, 32 times 157. We're going to add our 2 triangles, 1/2. And I'm going to start with my base of 157. And then the height of that triangle, we've got to look at it this way, is going to have to be using this height here in the middle to find. So that height of that triangle is going to be half of this distance across here. So that's 16. This is our 32 divided by 2. And then our height is 48. So if we're trying to find this thing right here, we have to use Pythagorean theorem. So that height of that triangle is actually going to be the square root of 16 squared plus 48 squared. And when I'm doing these types of problems, I use the store function on my calculator sometimes, and I can show that to you here in a moment, but that way you're not actually writing any of these parts down. You're just working it all directly in the calculator. So that's two of your circles, two of your triangles, and we have the other two triangles to add in. So now we're looking at the ones here on the edge. So to find the area there, again, two of them, 1/2 base, and this time the height is going to be half of the 157, and that's not even, so I'm going to go ahead and just write it out. We're going to have that squared plus the height squared, and then we've got to square root that whole thing. And I didn't leave quite enough room to show that very well, but that's going to happen there. So that's 1/2 base times height, and then times 2 for the two triangles. So that's everything that we have to type in, which is quite a bit. So if we're going to start that, I'm just going to start with what's there on the left. I would do 32 enter, 157 times. And then I'm going to start with the actual Pythagorean theorem part. We're going to use inner less if we go ahead and start with that part. So I'm going to start under the radical. I'm going to have 16 blue squared. I'm going to have 48 blue squared. I'm going to add them, and I'm going to square root. And then I'm going to kind of work my way backwards with that triangle part. So I'm going to type in the 157 times. And then I should recognize that the 2 and the 1/2 cancel each other out. So I have those two triangle areas. I'm just going to hit plus and add it to what I had before. So I actually don't end up having to use store on this one. But then we'll move on to this set of triangles. Again, that part's going to go away. Start with what's under the square root. So we'll have 157 inner, 2 divide. That gives us that part that we're looking at, and we want to square that. So blue x squared. We're going to do 48 blue squared. We're going to add those, and we're going to square root. So that's that height of the triangle times the 32 for the base. The 1/2 and the 2 canceled out, so we just add that to what we had before, and we get our answer that's right here. If we go and record that, we have 1.59 times 10 to the 4th, or move that decimal 4 times to the right, which means 2 zeros at the end. So that one did take a little bit more time. If they gave us the heights of the individual triangles, it would have been faster. But sometimes they'll give you the height there in the middle of the whole pyramid, and you have to do those two Pythagorean theorem steps to find them. Okay, last page of these that we're going to look at, we've got spheres again. We want the ratio of volume to surface area, and we just did this. We saw that whenever we did 4/3 pi r cubed over 4 pi r squared, that the r squared cancels out with 2 of these. We're just left with r to the first. The pi's go away, the 4's go away, and we're left with just 1/3 times the radius. So they give us the radius, divide it by 3, there you go. So in the calculator, we'll do our 5.27 inner, 3 divide. We get 1.76, and that's all I would write. I would not put times 10 to the 0. We've got a cube with an edge given. We want to find the ratio of the surface area to the volume. So we're going to have 6 times x squared for that surface area. And then volume is x cubed. So this time we have 2 x's on top and 3 on the bottom. So we're going to get rid of them up here. And then all but one of them go away down there at the bottom. So really we just have 6 divided by the edge. So that's what we're going to type in. Some of these are pretty quick. 6 inner, 7.81, divide. So we get 7.68 times 10 to the negative first, or just bump that decimal, this time 1 to the left because it's negative, and you get 0.768. And you do not have to write the 0. You could just write 0.768, and that would be correct as well. So any form of that you see there would be acceptable. This one does not look three-dimensional, but if we read the words at the top, it says this is the base of a right solid. So that means that it would be like a cylinder with just a funny shape, and there's a height that's going into the page that we don't see. So this is just the base of it we're looking at. So it's kind of like we have two half cylinders stuck together. We've got this one here that we can find the volume of, and then we've got this one here we can find the volume of. So I'm going to start with the larger one on the bottom. To find the volume of a cylinder, it's just the area of the base times the height. So pi r squared times height. But it's only half of it, so then we're going to divide it by 2. And we're going to do that for both parts of it. So I'm going to start with pi. I have the radius given, so we just have 10 squared. We're going to multiply by the height. They tell us the height of the whole thing is 8. And then we're going to divide that by 2, because it's half of it. And we've got the other part of that to add to it, so we're going to have pi times 6 squared times the height. We're going to divide that thing by 2. So we can go and type that in as those two separate parts. We could do our yellow pi. We could type in 100 instead of 10 squared. So 100 times 8 times 2 divide. You could have reduced some of that out before you got too far into it. So that was the larger part. So then we can look at the smaller part. We've got pi again. We'll do 36 instead of 6 squared times. We'll do 8 times 2 divide. So that's the smaller part, and we just add the two pieces together. So we get 1.71 times 10 to the third, or move the decimal over and get your 1710. Now you might notice that there's a lot there that's the same in both parts of that. So if you work enough of these problems, you might have recognized that off the bat and known that all of it was going to have pi times 8 over 2. And then really the only part that's going to be different, you have your 10 squared and your 6 squared. So you could reduce that, and you ultimately just do 4 times pi times 136. So let's type that in, make sure that does end up being the same. Yellow pi, 4 times, 136 times. And there you go. We got the same value. So sometimes you'll recognize that and save yourself some time by just using that distributive property, taking out the parts that they all have in common, and just working that addition with the parts that are different. Okay. We have a lot of work there kind of in the way of these other problems, so I'm going to go ahead and clear those off. We have on number 28 a cylinder with a cone indent. So it's not going to necessarily go all the way up to the top here. So it's not, that cone is not 1/3 the volume of the cylinder, but we just have that kind of random cone shape in the middle that shares the same area with our cylinder. So we are going to start with our cylinder. We have the volume as pi r squared times height. And we're going to subtract from that our cone, which is going to be 1/3 pi r squared, 1/3 area of the base, times our other height. So I'm going to call that h2 and go back and say that this is going to be h1. So I'm going to have the cylinder pi times the radius, which is our 3.81 squared. So pi r squared times the height of the cylinder, which is 7.21, minus 1/3 area of the base, so pi 3.81 squared. And this height, h2, the height of the cone, is 3.97. So you could do something similar that we just talked about. They both have pi and 3.81 squared in common, and you could factor those out. But there's still quite a bit left to do, so I would probably just work this one exactly as it is. I'd start with my yellow pi, 3.81, blue square, multiply it times the pi that was in there, 7.21 times. So that's the cylinder. And then move on to the cone. Save your third for the end. We'll do yellow pi, 3.81 blue squared times 3.97 times, get your 3 divide, that's your 1/3 of it, and then we want to subtract it from that cylinder, so we'll hit minus. we get 2.68 times 10 to the second, or you could write it with the decimal moved over twice, and you get 268. We have another right elliptical solid, so those showed up multiple times throughout the year. We need the area of the ellipse, so that's our pi AB, and we'll multiply it by the height, which is given to us kind of sideways here. So we'll have pi. Remember, A and B are half of these different axes, so we'll do the 16.85 over 2, and we'll do, just one parentheses there. We'll do our, we're actually looking for that minor axis. Look at me, not reading the problem. So this is what we're trying to find here. We're looking for B, and we're multiplying that then by the height, and that is the area, or the volume, sorry, which they give us that volume, because we did the area of the ellipse times the height. Sorry about that. So now that we are looking for the minor axis here, we are going to do a little bit of algebra. So we're going to start with that volume that was given. We're going to divide it by the height. We're going to divide it by pi. We're going to divide it by the axis that we do know. And then that's going to be b over 2. So if we want to actually find what, and it's not b over 2, and I'm not going to restart my video now, but this whole thing here is b, remember, and that's going to be just half the distance. So what we get there, that's half the distance across there. So the last step will be to double it. Sorry about this one. I evidently didn't look closely enough ahead of time. So when we go to put that into our calculator, start with the volume, 3437, enter. And we want to divide it by the height, so we'll do our 17.2 divide. We'll divide it by pi. We'll divide it by A, which was our 16.85 enter. 2 divide, that's A, so we'll divide by that. And that gives us B, which would be half of this distance. And we want the whole minor axis, so we'll just do 2 times. So we'll get 1.51 times 10 to the first, or move it over once and get 15.1. Okay. So again, I wrote a lot over the problem, so I'm going to go ahead and clear that so we can look at this last shape. So we have another tetrahedron where we're using that volume formula that's edge cubed over 6 square roots of 2. This time they go ahead and give us the volume, and we're trying to find the edge. So we're going to take that volume, we're going to multiply it times 6, we're going to multiply it by the square root of 2, and that's the edge cubed. So we're going to have to go then and do the cube root. So in our calculator, we'll do our 8721, enter. 6 times 2 square root times. And to take the third root, we'll do 3 yellow. And then on the square root key, we'll take that third root. So that edge we get is 4.20 times 10 to the first, or we get 42.0. These last 3 problems are geometry problems, but they're in printed form. They're stated problems that involve geometry concepts with our 3D shapes. So on number 31 here, you can see they all showed up at either number 59 or 60, both on the same page. The radius of a right circular cylinder. So sometimes I'll draw a small little shape just to help me picture it. So the radius is 485. The volume is given to us, and we want to find the height. So we know the volume of our cylinder is the area of the base times the height. So that volume is equal to pi r squared times h. So if I want to solve for h, I'm going to take the volume, and then I'm going to have to divide it by pi, and I'm going to divide it by 485 squared. So I picture it a little bit better if I write it one on top of the other like this. Okay. So in our calculator, we're going to start with our volume, 2218 enter. And this is what we're typing in right here. We'll do yellow pi divide, and we'll do 485 blue squared, and we're dividing by it as well. And we have to be careful with our units. In the problem, they gave it to us in centimeters for the radius, and then our volume was centimeters cubed, and they were asking for centimeters in the blank. So everything worked out nicely, but sometimes they ask us to do a conversion, so you always need to check that and make sure. So we get 3.00 times 10 to the negative third, or you move that decimal back 3 times, you get 0.00300. For the next one, we have a 35-foot section of pipe that's has an inside diameter of 3 inches. So we should recognize that we've got something in feet and something in inches. So you need to put them both into the same unit. And it's completely full of water. We want to find the number of gallons there are in this cylinder. So we have to know a fact that 1 gallon is equal to 231 cubic inches. So that means that we need to find that volume in cubic inches, and then we can change it into gallons. So we have the area of the base times the height, so we're going to have pi r squared. The inside radius is going to be half the diameter. So instead of 3 inches, I'm going to put 1.5. And then for the height that we're going to multiply by, we have 35 feet. So we should recognize that we have to multiply that by 12 inches per foot. And that then will get us the volume in cubic inches. And then as a final step, if that's how many cubic inches there are, then we're going to divide that by the 231 cubic inches that there are per gallon. And that will get us our final answer. So we're going to start with yellow pi. 1.5 blue x squared. And we want to multiply that. Then we'll do 35 times 12 times. And that is our volume in cubic inches. So then we do 231 divide, and that's how many gallons it would hold. So we get 1.29 times 10 to the first, or 12.9. The next problem is similar. Another cylindrical water tank, and it tells us how many gallons of water it can hold. So we're going to start with that number. And we know that there are 231 cubic inches in a gallon, so that's how many cubic inches we would have if we multiply that. That's the volume. So that's equal to the area of the base, pi r squared. They give us the diameter is 32 feet. So we want to change that into inches before we divide it by 2 here. So that's the radius in inches squared times some unknown height. We don't know. It wants us to calculate the height. But it does want us to calculate it in feet. So once we get our answer here, recognize it's in inches. So we'll take one final step and just divide by 12 at the end. We could have done some conversions a little bit sooner, but with our volume being in cubic inches per gallon there, it's going to be helpful to just approach it this way. So we're going to start with what's on the left-hand side. We're going to do the 523,000, enter, 231 times. So that's our volume. That's our cubic inches. So then we come over here and look to see what's on the right. We want to leave h there, so everything else has to be divided by. So we're going to do yellow pi divide. That moves it over. It moves it over here. Then we've got to take care of all of this. So we'll do 32 enter, 12 times, 2 divide. So that's the radius in inches. We're going to square it, blue x squared. And then we also want to divide that into the volume. So we'll hit divide. So that's the height in inches. Our final step will be 12 divide. And we get the height of that cylinder, 8.69 times 10 to the first, or 86.9.